This is exercise 7.4 from Introducing the Theory of Computation by Wayne Goddard. And the exercise reads, construct a PDA for strings that consist of 3 parts, where the first part is a binary string, the second part is the symbol pound, and the third part is the reverse of the first part, which is essentially palindromes with pound as the middle symbol. So this machine here starts you in state 1, you epsilon transition to state 2 and push a delta onto the top of the stack. From state 2, if you read a 0, we push a 0 onto the stack. If we read a 1, we push a 1 onto the stack. If we read this pound symbol that should be in the middle of our string, we're going to transition to state 3, where if we read a 0, we'll pop a 0 off our stack. If we read a 1, we'll pop the 1 off our stack. And once we reach the end of our stack, we pop this delta placeholder off and go to state 4. And if that's the end of our string, we'll stay there because that's our accept state. So let's look at this in Python. We just have our collection of states here. This machine 7.4 takes an input string, breaks it into a list of characters, L. POS is our position marker that just tracks where in the string we are, what our next character to evaluate is. S is our current state, set to state 1, our start state. Our stack is a Python deck, and our result is set to false at the beginning here. So this is a redundant check. We'll always be in state 1, but this mimics the epsilon transition at the beginning of our machine. So if we're in state 1, we move to state 2 and append a delta to our stack. Append is our push method. So while our position counter is less than the length of L, we'll still have characters in the string to evaluate. So while that's going on, if we're in state 2 and we read an L at our next position, or sorry, we read a 0 at our next position in L, we push a 0 onto our stack and increase our position counter, and this continue pushes us back to the beginning of our loop. So if we're in state 2 and we read a 1, similar to reading a 0, we're going to push a 1 onto our stack and increase our counter. And if we're in state 2 and we read a pound symbol, we're going to move to state 3 and increase our counter. Once we get to state 3, if we read a 0 and we have a 0 at the top of our stack, that's what this stack -1 checks. We're going to pop the 0 off our stack and increase our position counter and continue. And if we're in state 3, we read a 1 and we have a 1 at the top of our stack, we're going to pop the 1 off the top of our stack and our position will increase. If we ever find ourselves in state 3 reading a 0 with a 1 at the top of our stack, or our delta here, or we're reading a 1 and we have a 0 here, or our delta here, or nothing at all, we'll hit this break statement and break out of this loop entirely, because that's not a valid string for this machine. So once we get to the end of our the end of L, our position counter will no longer be less than the length of L, our input. We do this check, we make sure we're in state 3, the top of our stack has a delta, and we've evaluated every position in L, and we'll advance to state 4. And if we're in state 4, our accept state, at the end, we flip our result to true and return that result. So these are some example strings here. The first 4 are in the correct form. The second 4 are not. So we'll give this a run. And you can see we've got 4 trues and then 4 falses. So that is exercise 7.4.